Good afternoon, everyone, wherever you may be in the world. This is the next in our series of webinars with Fred Chiesler. We are going to be following the same format we've been using for a little while, which is Fred's going to present. As Mike said, you're more than welcome to ask questions as you go along. The chat window seems to work quite well as that process. When we finish the presentation, we will invite you, if you want to actually open up the mics on your phone line and talk to us. More than welcome to do that. The whole event is being recorded. It will be online shortly. The other thing is that the white paper that Fred is presenting the slides around at the moment is available in read-only mode. Shortly after the end of this presentation, it will be flipped open so that you'll be in comment mode. If you haven't used that before, it's very simple. All you do is, if there are any parts of the text that you want to comment on, you simply highlight them and right-click and choose comment, and you'll be able to add the equivalent of little post-it notes in the document. That's pretty much about it. If you have any problems or questions during the event, please just pop a question in the chat window and Mike will be able to assist on any technology issues. Okay, with that, Fred, take it away.
All right, well, good afternoon, everybody. I can see from the participant list a number of familiar names, so it's nice to see you all, and I'm looking forward to getting some feedback from all of you and giving a little bit of an overview of some of the issues that we've been discussing, or at least that we had discussed this past summer, just to provide a little bit of background for those of you who may not have been completely brought up to date on what's going on. We're trying to understand what are some of the biggest issues, some of the biggest research issues that we want to try and address through the astrobiology program in the next 5 to 10 years. Try and identify what are the key milestones that we want to work towards, what we think is achievable, and what the priorities may or may not be. So this summer, the way that this began is we had a small workshop held where there were small groups put together to identify some of the bigger questions that were raised that we think need to be priorities over this time frame. And within those bigger questions, identify what some of the smaller questions and particular milestones what may be achievable and where our priorities should be. Now, because of the workshop being short and only bringing in a small group of people from the community, we recognized that this was not going to be anything close to an exhaustive list. So the goal of today is to give you an overview of some of the issues that we identified, some of the things that we talked about, and open it up to the community and bring in open this up for feedback on what we did discuss, and also identify things that we didn't put into the white paper that also belong there. So this is very much meant to be a constructive community effort, and so that's what we're hoping to get here. So what I want to do today is just highlight one of the bigger questions that we identified this summer, identify kind of what we thought about the issue, how it connected to other aspects of the astrobiology program and the research goals that were identified, and use that really to motivate what I'm hoping will be more interactive discussion after my hopefully very brief presentation. But the big question that we identified was, how do habitable planets form? And so I'm going to step through some slides here that mostly provide an outline of the white paper that Andy was just making reference to, that everyone can view. And so the first thing that we started off with was just a question of what. What do we mean by this? Why is this an important question? So let's start there. One of the things I did was I went to the astrobiology website on NASA and just tried to take the definition as it's outlined there. And it says that astrobiology is the study of the origin, evolution, distribution, and future of life in the universe. And so in terms of the question of how do habitable planets form, what we're really working to address here are the latter parts of that definition. That is, the category that falls in the category of addressing the distribution, where might life be in the universe, and what is the future of life in the universe? Where would it survive? Where could it migrate to potentially? Really, whatever our imaginations allow for. And so the reason why we wanted specifically to focus on habitable planets and where they may exist is one of the amazing things in my mind that we've come to recognize in the last few years, and particularly most recently, is that planets are abundant in the galaxy. We're finding them everywhere. We knew they existed elsewhere for a while, but now we're really beginning to appreciate how common they are. And so this is telling us that the process by which planets form, the general astrophysical process by which these planets form, is common, and that planets really are a natural byproduct of star formation, something that we tended to already believe or hope, but now we really have the data to support that with the identification of how common these planets are. Now, in terms of habitable planets, however, we know that just because you form a planet, you're not necessarily going to form a habitable planet. And so what we want to begin to address is how did the details of these different astrophysical processes and the sequence of events that led to the formation of planets, how could they have impacted the properties of the planets that they do form in terms of where they are, their chemical composition, and whether or not these planets really are what we would term habitable, that is, planets that are capable of allowing life to form and for that life to thrive. And so that's what we're looking for very broadly in terms of habitable planet formation. So why do we want to understand this? Well, there's a couple of different reasons, but our specific goal here is to understand the physical and chemical processes by which our own solar system forms. One thing we take for granted is that we have a habitable planet in our solar system, but there are still many questions about its origin and how it came to be. So we want to understand how that happened in our solar system and use that information to evaluate how common these type of processes, this formation history that our solar system experienced, how common these types of processes may be around other stars, or if there are other sequences of events that may lead to the formation of potentially habitable planets. And really, this is a necessary step towards understanding how many habitable planets there are going to be in the galaxy or in the universe, where those planets may be, and ultimately whether or not there is life elsewhere in the universe. So by addressing this question, we were beginning to try and understand where exactly in the universe this could be and how common it would be. Again, going back to the definition that on the Astrobiology website. So this is not meant to give the impression that this is going to be an easy task, because there are certainly challenges that we have to deal with, some of which are motivated from the questions that we're going to come to in a little bit. But some of them are just some things that we take for granted as well. And so the first is that we don't understand entirely how our own Earth formed, or the conditions by which our planetary system formed. This is an active area of research. And right now we only have one known habitable planet in the universe. So we do need to understand how that planet formed. We don't immediately just turn to planets elsewhere, assuming that we can use our Earth as a model, because there are details and questions that need to be filled in. And just the general process of planet formation, we recognize that it's a very chaotic process, with the outcomes depending sensitively on the initial conditions. By definition, that's what chaotic is. But what this does is it means that we have to be very careful in terms of how we go about addressing this. The models that we develop to look at planet formation today are capable right now of producing many different outcomes given slight changes in their initial conditions. And that doesn't, just because we don't reproduce our solar system or reproduce different planetary structures, does not mean that those models are wrong. It just means that we may not have a great understanding of the initial conditions from which we're starting. So in many ways, one of the things that we have to try and do is look at this as a probability issue. Given that we're not going to be able to, we're limited in terms of the details of the initial conditions, details of some of our starting points. Just because we put together a model, it doesn't that takes those and moves forward to make predictions about habitable planets or the properties of any planet. If we fail to reproduce what is observed, it doesn't mean that the planets or the models are wrong, or the processes that we modeled are wrong. It just means that there could be an issue with the initial conditions. So this really is something that requires detailed interactions between theory and observations, making sure that we have this interplay, this cross-disciplinary approach to really use the different approaches that we in the community use to educate one another and work together to make advances towards answering these questions. And the third challenge is that while we talk about habitable planets in a very broad sense, and the goal ultimately is to identify planets that may harbor or allow life to form and evolve, we don't necessarily know all of the ingredients or qualities for those habitable planets. We use the Earth as a model, and that's a natural starting point because it is the only habitable planet that we are aware of. But we do have to be open to the possibility that the universe and nature is much more creative than we are. And so we want to begin to think about the different processes or different outcomes that you may get, and whether or not they are conducive to allowing life to form and evolve. And again, this requires interdisciplinary approaches, communication with our biological colleagues, and not just limiting this to a question for astrophysicists, astronomers, or cosmochemists. So this really is a challenging question, but ultimately one I think that has a high impact and is important and central to the field of astrobiology. So because of some of these challenges, and before getting into the details of some of the questions that we identified within this particular broad question, I do want to point out that there are a number of related questions that were identified at our workshop this summer and have been discussed or will be discussed in separate webinars. And I've listed some of them here on this slide because I think that it's important for us to recognize that this really is a broad question and it requires understanding many different aspects of topics within astrobiology. And so we don't want to look at this as an isolated question, one that we can go work on independent of one another, but really stress the point that this is something that's going to require a community effort to make advances in, and we have to be aware and communicate our ideas across these questions and not work independently of one another. And these questions, when you get a chance to look at the white paper, these particular related questions are listed at the end of the white paper so that you can come back to it. And if there are webinars that haven't taken place, I encourage you to sit in on those as well and discuss them, because as I said, they will have an impact on the questions that we're discussing today. So some of the fundamental questions that we wanted to address within this broader question of how do habitable planets form, we identified, I think, the slides may prove me wrong, 4 major sub-questions that we thought needed attention. And within these sub-questions, there were even a lower level of questions that we identified and list on the white paper. I didn't want to list all of those on these slides, although I'm hoping that the text I have here summarizes them. But again, I do want to encourage you all to go through the white paper, look at those, and provide comments on the particular questions and raise questions yourself that you yourself believe belong on there, whether or not they fall into the broad questions I identified here or possibly fall under a needed question that we've left out. But the first thing that we identify is just the question of how does planet formation vary with stellar properties. One of the things we typically think about is an Earth-like planet around a Sun-like star, and that's where a lot of our ideas and models just from planet formation alone, never mind the question of habitable planet formation, actually begin. But we recognize that the stars come in a variety of flavors in the galaxy. There are stars that are much lower mass than our Sun. In fact, most of the stars in the galaxy are lower in mass than our Sun. There are stars that are higher in mass. There are stars with different metallicities, different abundances of heavy elements in them. And so these are all issues that are important and could have an impact on how planet formation proceeds. Never mind just the question alone of habitable planet formation. So we want to understand how these different processes or these different qualities of a star could impact how planet formation would proceed around these different stars. Also extending this to not only just the properties of the star itself, but the environment in which that star is born. Is it born in a very massive cluster? Is it born in a low mass cluster? Or where within those particular clusters it's born? All of these could, again, impact the outcome of planet formation. And again, I stress that because of this chaotic nature of planet formation and the dependence on the initial conditions and the timing and sequence of events that could occur in these systems, it's important for us to recognize that this is going to be something that is going to come down to statistics. For example, just speaking very broadly and not meaning to motivate a particular argument here, if we were to find that habitable planet formation or planet formation tends to produce a planet in the quote-unquote habitable zone more often in a star like our sun as opposed to a low-mass star, for instance. I'm not citing any work that suggests that. That doesn't mean that we should completely rule out the possibility of habitable planets around low-mass stars. It just means that the statistics of likelihood may be lower. However, given the fact that low-mass stars are so much more abundant, they still may be more attractive in terms of looking for habitable planet formation just due to the numbers involved. So these are the things that we need to try and quantify and look at if we eventually want to look towards identifying and searching for habitable planets in the galaxy. By understanding how these processes operate around different stars of different types, we may be able to educate and motivate future studies and provide guidance as to where these studies should be focused. So again, understanding how these things depend on the properties of central stars is an important thing. One thing that is particularly close to my interest, but something that we recognize as being very important in the workshop that we had this summer, was the recognition that chemistry of planet formation is often handled separately from the physics of planet formation. We outline a sequence of events as to how planets would form, starting with the collapse of a molecular cloud core, formation of a disk, coagulation of dust, forming planetesimals, and those planetesimals accrete to form planets. We talk about those very generically, and then we start looking at how chemistry would be affected by these different processes. But there's really going to be an intimate feedback that occurs between the chemical and the physical evolution of materials throughout all of these processes. As things begin to vaporize, as they are brought across close to the sun, their chemical properties are going to change, and therefore what they could then be incorporated into at later stages of evolution are going to be important. And in many ways, this is important in terms of starting or helping to establish what the initial conditions are at the different phases of evolution that we often study. How are things processed when the molecular cloud core collapses to form the protoplanetary disk? How much of the molecular cloud material is directly inherited? How much of it is destroyed during that formation? And this is going to be important in terms of setting things like the abundances of organics within a protoplanetary disk, or the ability of different molecules to take part in chemistry within the disk. And so this is, again, an important feedback. We need to understand how these two things are really coupled as opposed to treating them separately. Now I just talked completely without even reading the text on my slide, so I want to make sure that I haven't forgotten any of the points here. But again, looking at how the physical processes set the initial distribution of materials within different epochs of planet formation is going to be important, because this really will set the inventory of materials that are potentially delivered to a habitable planet, and whether or not that habitable planet can accrete the key elements and volatiles that we think are necessary to the formation and development of life. All right, next slide. The roles of giant planets. This is an important one in many ways, because giant planets are exciting because they're easier to see around other stars than the small terrestrial planets that we typically think of as being hosts for life. And again, I stress typically because I don't want to limit ourselves to any particular dogma or ideas out there. Recognize that there's lots of possibilities out there. But giant planets in our own solar system, we are seeing that what happened with Jupiter and Saturn would have had a dramatic effect in terms of how the formation of the Earth and Mars and Venus would have proceeded in the inner solar system. In many cases, you can still form planets in that region regardless of the details of what happens with Jupiter and Saturn. But in terms of the accretion history and where material is brought from to be accreted into these terrestrial planets, it does have an important effect in terms of when these planets formed, whether or not they migrated, and to what extent they migrated. And there's even beyond that the issue of what role did Jupiter play in the subsequent evolution of the planetary system in terms of stabilizing the orbit and possibly removing the debris that was left over from the formation of the planet. These debris could have potentially posed hazards to the formation and development of life. You think about like a KT type impact. In many cases, you worry about how impacts from this leftover debris could have sterilized the surface of a planet if there were significant impacts over time. but also the potential for, if those late impacts were maybe beneficial in that they delivered volatiles or key elements to the development of life. We don't want to necessarily say that removing all that debris is necessary. And maybe Jupiter's presence was helpful in that it excited the orbits of some things that were brought to Earth that then played a key role in allowing life to gain hold on the surface. So we want to understand, how did giant planets affect all of these things? And then what types of orbits or structures or properties of giant planets may be conducive to the formation and maintenance of a habitable planet, versus what properties may be problematic, and therefore by detecting giant planets, maybe you can outright exclude the possibility for a habitable planet existing in a given planetary. So there's a lot of open-ended questions there, and we do identify some of those in the white paper. But there's, when we just think of formation of habitable planets, I think it's important for us to also think about what else is going on in that planetary system and how could it impact both the formation and the long-term evolution of a planet in that system. And then the other thing that we identified is recognizing that we're at a very important point in terms of observational data that can be collected. There's a number of new facilities that have just come online or will be coming online or made available in the coming years, both ground-based and space-based. And these are going to provide new opportunities to make new observations that have to date been technologically limited and unavailable to us. So what we want to do is recognize in the short term, in the next 5 to 10 years, what kind of information can we really tease from the observations that will be made from these facilities? And then how can we use that information to further educate our ideas on how planets form, test the models and hypotheses that are developed as we look at some of these other questions that have been identified or are identified in the future on these white papers, and really maximize the scientific return there. Looking at the connections between some of the observations that will be made and the issues related to habitability. Because ultimately we want to, again, maximize the scientific return and understand where habitable planets should or do exist within the galaxy, and then be able to make the observations of those planets and start to really understand what those planets are like. And by maximizing all of our observational and modeling efforts, that's how we're going to take a step forward to really looking and then identifying those habitable planets. Outside of our own galaxy, outside of our own planetary system. And so this is just the final slide here, and then what I want to do is open it up to discussion. But those were the 4 basic questions that we identified, and as I said, those were not meant to be exhaustive in any sort of way. We recognize that there's many more out there, and we want to get the feedback and help identify what did we miss or where should the priorities be in the different questions that we did identify. But really, one of the key points that I want to go back to is, why are we studying this? Why do we care about this? And why do we want to understand habitable planet formation? And why do we recognize that as being an important part of, potentially important part of the roadmap moving forward? And the first is that it just completes the story of our own origins. It's, two of the fundamental questions that we're always asking in science is, where did we come from and where are we going? Well, understanding how a habitable planet forms means understanding where the Earth formed and understanding where we came from and how we fit within the Milky Way. And so I think that's just a fundamentally important question, both from a scientific perspective and from a philosophical perspective. And to me, that's one of the things that I'm really excited about here in terms of being able to possibly work towards understanding that. Again, it allows us to understand our place in the galaxy. We can address the question of how many habitable planets there are in the galaxy. Where else are they? And how do they compare to the Earth? And do they potentially harbor life? So it tells us where we should be looking for life. And to me, these are some of the most exciting things that we can begin to be working on. Why we should be looking at these questions. But it is important to recognize that we don't immediately jump to these broadest goals. This is what's motivating it, but there's a lot of important benchmarks we need to meet along the way, some of which we have identified, and hopefully some of which we'll identify through the discussions that we have here. So what I would like to do, as I said, I think that is the final slide here. I'd like to open it up to discussion. I see Andy's coming back online. And however that's going to be, whether we open the phone lines or open the chat window, but hopefully we'll have a productive conversation next. And I look forward to hearing from you.
Great, thank you, Fred. For anyone who hasn't been to one of these before, what we found works quite well is by all means type your question into the chat window if that's easiest for you. But the phone lines are open, and if you want to talk directly, I always have to do this the right way, up at the top of the bar there, you'll see a little icon of somebody with their hand in the air. And if you click on that, it just gives us an indication that we can bring you into the audio call. So Dave has taken first bite at it.
Well, thank you, Dave. I always like to start off with a compliment. I think many people, we were given some very broad guidelines, and I see Michael is typing, so he can give some overview as to, we're kind of given a general template with which to work. And so I don't know what other people have done for the white papers completely. I've seen a few others, but I think the general format here is fairly common.
Great. Other questions or observations? What else might the team find useful to be aware of or think about in terms of this paper? And also, what might it connect to your own thinking if you're involved in writing papers? Have you seen connections there that would be useful to identify?
Right. Yeah, I'd be very interested to see, some of the things that people are thinking of that we neglected in terms of what we've identified here, or things that you think are particularly important, maybe that we have identified, but you want to make sure are stressed as being fundamentally important. And as I said, this really was a team effort, and so I'm just representing the team here, but I see Steve Vance is on here, and he was one of the co-authors of this white paper, as were Steve Moises and Alan Voss and Rory Barnes. But as we said, this is not a complete sampling of the community, so there's going to be many things, many other viewpoints that people have, and so I'd like to hear them.
Well, I have another question that's sort of generically related to that, and that is at the very top level, the title of your document, you feel very strongly that this should be included in the strategy document, and then maybe as we go down to the next level, you'd like to think that in your biggest headings in your document that you've really captured the breadth of this area. I mean, at some point at the top end, you've got to feel like you've really defined the perimeter of this area. But then as you drop down maybe to your sub-questions, you're in a mode where these are examples of questions, but that's not the unexhaustive list. You see what I'm getting at? I mean, at some point at the upper end, you really feel like you've captured it all. But as you drop down to a lower level, you're just giving examples so that, just don't think they're being excluded necessarily. So how do you feel how that plays out in what you presented today?
Well, first, I'm sorry, my recognition isn't very good. Could you identify who you were?
I think that was Dave, wasn't it?
Dave Murray, yeah.
So that's a good question. And in terms of whether or not you should think of the document as being complete, I would say that we recognize that there were going to be things that needed to be added and needed to be kind of integrated into everything that we identified. And so when we were working on the document, we weren't trying to tie everything together at the end to bring it back to that top level argument that, as you identified. And that's something that does need to be done. I agree with you. And so, again, the document is going to be something that continues to be worked on and edited. And ultimately, the paper, and I don't know if Michael wants to comment on it now, but again, this is all ultimately meant to be useful in terms of guiding the development of a roadmap or strategy, as I understand it. This isn't meant to be something that's going to be stapled together with the other white papers to represent the final word on what the astrobiology program is doing. But I agree with you. It's important to bring that all back together. And once we feel like we've got a more complete list that the community is happy with, we'll work to integrate it together to complete that story. But I think it's a good point, and I thank you for the feedback there.
let me just say it a different way, and that is at the very top of your document, at the biggest, highest level, you're really defining for people what the field is, what this part of the field is, and that's very educational. And then at somewhere in the middle, you're beginning to set priorities for what you think really should be done in the next 5 years. So you're necessarily narrowing it down a bit. Look, okay, this is the whole field, but this is really what we need to deal with in the next five years or 10 years or whatever. And then at the bottom level, you're giving just examples, not all inclusive, but examples of how you might proceed. You see what I'm getting at? You're sort of grading from being all-inclusive to prioritizing to giving examples. And I see how you can do that with your structure here, and that's why I like it. But I just, so I think maybe if there needs to be input at this level, it's in this area of what really is important for the next 5 to 10 years, sort of that middle tier in the organization. And if there's any sort of feedback where people feel that there needs to be input, it would seem to me that that's the key point, or key part of the document.
So in developing these, I think, I agree with you that, the way we were thinking about it is it is important to kind of identify both the broad picture and also kind of identify the fact that there are tractable or achievable goals in the short term, because this roadmap is meant to kind of educate or illuminate what we should be working on next. But maybe one thing we can do at the end of identifying those kind of fine questions is have some discussion about how they would fit into addressing the broader goals and the bigger picture that we outline at the top level, and kind of bring it back to show that how this would all fit together. Is that something that you kind of fits with what you were describing there? Did I understand that properly?
Yeah. It's just this combination of objectives that you're things you're trying to achieve. The general definition of what this area is. Where you guys see the priorities in the next 5 to 10 years, and then just giving people examples of things that could be done that moves in that direction, and that's not totally exhaustive list. And then I like your sort of coming back at the end to connecting it back to all the other things that motivate us. Those are always valuable parts of a document like this. I mean, this document is intended to motivate as much as prioritize.
Right. Exactly.
So.
No. All right, I appreciate the comments, and that'll be something we'll be mindful as we develop these.
Fred, we have a question for Alicia.
Yeah, I see Alicia Weinberger typed some questions into the chat, trying to figure out the bounds of astrobiology, and this is an excellent question because this is something that we somewhat wrestled with ourselves in having these discussions. So her questions are, for some examples, are there observations of circumstellar disks that would not be relevant, given that these disks are eventually going to form planets? Could you imagine something that's going to be a measurement that isn't going to have some impact on whether or not habitable planets would form, or other questions related to astrobiology? What observations of young stars themselves would be relevant? For example, abundances, magnetic fields, flaring rates. And Alicia, I think that's an excellent question. It's something we wrestled with as well, because it's kind of, I don't know that I myself am capable or in the position to discuss what the bounds are, but I can offer my opinion, and hopefully other people will chime in as well. I think it's hard to say something is, when you're talking about something as broad as planet formation, when you're talking about how stars form or planets form, clearly that's an important thing to understand towards how habitable planets would eventually form. I wouldn't go all the way back to saying the Big Bang is necessary to understand in terms of astrobiology, even though that was clearly what set everything in motion to eventually lead to the formation of habitable planets. And so there is this question as to what are the bounds. And so the argument I would make is that if you can demonstrate in asking that question how that data, for example, taking your first question, how an observation of a circumstellar disk would help us better understand the question of habitable planet formation, or whether or not these habitable planets form, or the connection between circumstellar disks and the potential for life forming in these planetary systems. I think that that falls within the realms of astrobiology. If you're just trying to understand the surface density distribution because you want to look at planet migration, yes, you could always make that connection, but I don't know. It's something we wrestled with, and I see Steve is typing, so I'm hoping he can remember some of the conversation we had this summer about it. But it is a very gray area. And I think that's one of the things that makes astrobiology very interesting, but also leads to, since it's so open like that, it's hard to completely know where something ends and something else picks up. I think that's
Steve, if it's convenient for you, you can unmute your phone and talk rather than type. Oh, okay.
Yeah, I'm in a shared environment, so I won't speak for too long. But yeah, we touched on magnetic fields around other solar systems. We didn't really know what to do with it from, as I recall from our meeting. But I attended this KISS workshop that I linked to subsequent to our meeting. I found it really hugely exciting. The workshop focused on the possibility of measuring magnetic fields around exoplanets. And maybe that's something that could occur in the next decade. It didn't really make it into our document, but I hope it figures into discussions down the road.
Great, thank you.
But yeah,
so this is Alicia, if I can just jump in verbally.
Please do.
So I would argue for an expansive definition of astrobiology when it comes to astronomy. And part of this is just from my bias that I don't think there's enough astronomy in the current Astrobiology Institute, that the astronomical questions that we ask are so central to whether or not there are other habitable planets that has to be considered a core part of the Astrobiology Institute. And so even questions like general questions of giant planet migration, I would argue, are also essential in your example, Fred, because without understanding the migration of the giant planets, we have no idea what systems we can currently find that might also host habitable planets. Right? So we have a certain census already, and we don't know whether that census is likely to include a high fraction or a low fraction of planets that we don't detect, but which could actually be habitable. So I would err on the side of letting people, write their own expansive connections to astrobiological questions from an astronomical perspective, but I was curious what you guys had discussed.
No, and I think you make excellent points, Alicia. And your view was shared at the conference by some of the participants, and I'm being very general and not stating my own personal biases that completely agree with you. But I think it's one of those things where whenever you have a very broad field like this, something that is very interdisciplinary, there's a potential for a lot of things to feed back and be important in all this. And I think what's important is that we have to demonstrate, as moving forward, how particular observations or studies are going to further the understanding of the question of life elsewhere. So from the sake of wanting to know how magnetic fields impact planetary migration, for example, yes, planetary migration is important. And so I think it's up to the people to demonstrate how that ultimately leads to an understanding of habitable planet formation, rather than just saying, well, anytime you talk about a planet, you talk about habitable possibility of being related to habitable planet formation. I think it's up to us to continue the thought process all the way through and demonstrating in terms of the astrobiology program how this impacts the potential for life to be, or habitable planets to be affected by the processes we study. I hope that makes sense. But I do agree.
I'd like to direct a question at headquarters on this, and that is that these are all very important things for the Science Mission Directorate of NASA to be supporting. But I guess my basic question is, what does the astrobiology program want out of this document that gives them guidance as to how their program will make its particular emphasis or contribution to this overall area?
I guess I'm trying to understand what you're asking. We're looking for a description of exciting future areas of this field, and that will naturally impact our calls. It'll impact what we do in the institute. It'll impact in the long run. It'll impact how we try to sell astrobiology to other parts of NASA and so on. I guess if you're asking me, is there going to be a one-to-one mapping between major topics in this document and calls for proposals or something, I mean, the answer there is probably not. But
okay.
we're looking for, strategic guidance.
Just across the broad field of planet formation, and then from that you sort of...
Do you mean particularly in planet formation?
Well, how do planets form? Yeah, I mean, right. I mean, we heard about research that addresses all the aspects of what happens in a disk, and they're all very relevant to the formation of the habitable planet. Is that something that all of which the astrobiology program will support, or what? I don't know. I mean, I'm just trying to keep it as an open question.
So I think there's two issues. The first is, what are the open questions that are related to astrobiology? And the second is, what particular topics is the astrobiology program going to fund? And those are not necessarily the same. So there are certainly going to be some aspects of planet formation, such as giant planet formation, for example, which astrobiology program in and of itself may not fund, but certainly other parts of the Planetary Science Division at NASA will fund. We already fund them in the Origins of Solar Systems program.
But those kinds of decisions are downstream from this document. We shouldn't worry about that.
Absolutely. Correct. These are downstream. These are going to be regularly reassessed at headquarters. I wouldn't worry about it in this document. The purpose of the document is to give a skeleton on which the community as a whole will build the next decade of astrobiology-related research.
Okay.
Freddie, do you want to pick up on Alicia and Gabriel's points at all in the chat window?
Well, I was just going back through the slides here to address Alicia's question here about a potential missing item from the white paper. What measurements must be made prior to the design and launch of a mission to take spectra of terrestrial planets in habitable zones? And so some of the other questions that were identified at the workshop, and there will be some discussion, may actually be related to that. And this is a good place for us to have this dialogue. Does something like that fall more into this broad question, or something like the question of how would we identify and recognize a habitable planet? That was a separate question that I believe is going to have its own webinar, or it's being folded into another one down the road. How would we recognize an inhabited planet? Those types of things. So Alicia's question is about, launching a mission that would actually observe planets in the habitable zone. And so does that relate to the formation, or does that relate to some of these questions here? So Sean just commented that there will be webinars on spectral interpretation of exoplanets. So I don't know, Alicia, if that satisfies your comment there, or if you feel like that should be discussed further here.
Well, for example, one current item, right, is the detection of how much terrestrial zone dust there is through projects like LBTI, right? That was considered essential information for designing a future mission. That's happening in the present, so it doesn't necessarily need to go on the roadmap. But my thinking was more, are there similar questions that we would require the answers to for mission-driven reasons, as opposed to just from pure scientific reasons?
Right.
And there's lots of people thinking about those missions who would have a better answer to that question than me.
And they would have better answers than I do. I think this somewhat ties back to the discussion that Michael was chiming in on about what the goal is here. And it's very, there's a lot of questions that we can ask that we're all interested in answering, but some of these questions, in order to answer them, require a very long effort. And so part of, as I understood it, and I hope Michael doesn't get upset with me by a misunderstanding, but as I understood it, part of what we're trying to do here is identify what are the big kind of important questions to ask, but what are the achievable goals in the next few years that this document is meant to provide guidance and prioritize in terms of the efforts that will be made. So yes, we want to understand life on other planets. That's a great question or a great objective, but we're not going to be able to do that in the next just couple of years. But what can we do to start marching towards that, to put us in a place that we can answer that question as we continue to build upon the science that we're already doing and the science that is going to be done in the next few years. And so as I look at it, what we're trying to do is identify kind of what efforts should be made most immediately towards answering some of the very broad goals that we're identifying here.
And I can see that Sean is cross-trailing a future webinar, building up the audience for his one.
Yes.
So that's useful.
Advertisements and self-plugs are welcome.
Other questions or observations that would be useful for the team, points you'd like to debate at this point? Just while you're thinking about that, the switch has now been flipped, so if it is more appropriate or more useful for you to comment directly in the document, you can do that right now. If you had it open at the time, you may need to close it, or you may need to refresh your browser to get the changed status on that, but it is now open for your commenting. Other thoughts?
Well, just to make a comment that I think your choice of the major questions, stellar properties, chemistry of planet formation, giant planet, I think in a way you've really captured what looks to me like a waterfront for this. So just as a vote from that column, I just thought I'd mention it.
I appreciate that. Yeah, and I think in many ways those broad questions cast wide enough nets that some of the sub-questions we identify, many of the sub-questions that we identified were able to fit pretty easily into one of those categories. But one of the things I think is going to be most interesting is many of us who were there were, as I said, you can see who the people were that put together this document. Many of them were largely theory-centered people in their own research, and so I would be very interested to get the observers, and I'm glad Alicia's commented on this because she's certainly one of the best positions to do so. But commenting on what, from the observational perspective, what is missing, where some of the priorities should be, and some of the efforts should be made. Because I know what I would like to see being measured. I don't know whether it's possible or not. So, educate me.
I'll chime in. Fred, thanks for leading this discussion. I think the document's really taken a nice shape. I'm hopeful that there will be a lot of input from the community of researchers who aren't expressly looking at exoplanets, as you mentioned. Getting some impressions and some creative feedback from people who study biology might be a really great way to brainstorm what new measurements could be made, what's missing from this document. Wondering what's the timeline for contributions to the document?
Andy, do you know?
Now that it's opened up to the community.
That's a good question. We haven't actually set an official cut-off time. I think the discussions that we had internally is that in the new year, February, March time, I'm anticipating that we would have some sort of convergent process. Michael, is there any more informed word on this subject?
No, not yet. We probably need to start working out the details of how we're going to do the integration. But certainly by the February-March timeframe, we'd like these documents to be as close to, I don't want to say done, but as close to paused as possible.
So
I'm imagining one function of this document being then in that time, I'm at a meeting or even at a party, and I get into a conversation that touches on this document, that I can give someone this link and say, hey, go look at this, and feel free to leave a comment or add something to it.
Yeah, absolutely.
About this at any party.
Okay.
So.
Yeah, it's a great line for a party. Come and comment on a document. So yes, all the documents, as we move through the webinar series, all of the documents will be opened up for commenting and will then stay open for commenting until February, March time, when there's a sort of convergent process on that. Probably just to add an interpretation to that, though, it would be helpful if you didn't see the February, March time as the deadline, and therefore that's the time you put in your diary of, oh, I must add my comments then. Sooner is more helpful than that. So you could think of the deadline as the end of next week.
And also because hopefully the comments will stimulate some discussion and exchange, not just, be something that we pack in every single comment.
Right. What we have set up for some of the earlier documents was we created a discussion thread for each document on the Astrobio website. That hasn't been used. People have tended to just put the comments straight into the document. However, if it seems as though that's helpful, we can, of course, always set up discussion threads for specific documents if people want to talk about things in a broader context than just making annotations to individual sort of blocks of text. It's also, we're more than happy to set up additional topic-specific webinars if a group of people say they want to get together and talk about that. So the purpose of these events is really just to show the papers to the wider audience, start soliciting comments, and then if we need to organize additional events, we can. Thank you. Cheerio.